Good day, boys and girls. This is Mrs. Smith, and we're going to go over the Grade 5, Chapter 8, Fractions and Decimals Study Guide for the end of your chapter test. We are going to start with the greatest common factor for each set of numbers, and we're going to show your work, okay? All right. Now, I use factor rainbows. If you have a different method, you are certainly welcome to use that. I love greatest common factors because the initials actually tell us the directions. So I always write G, C, F, and we work backwards. The very first thing we're going to do is list the factors for both numbers. So we have 36 and we have 54. All right, so for 36, we have 1 times 36. We have 2 times 18. We have 3 times 12, 4 times 9, and 6 times 6. For 54, we have 1 times 54, 2 times 27, 3 times 18, we have 3 times 18, and we have 6 times 9. Next, we're going to circle the factors they have in common. 1, 1, 2, 2, 3, 3, 6, 6, 9, 9, 18, 18. And of the ones we circled, which is the greatest? Well, that would be 18. So the greatest common factor for 36 and 54 is 18. All right, next we have 100. Now this is 3 of them. We have 123. We have 54 again, and we have 27. Now, because we wrote 54 over here, well, actually, you know what? I should write it again, just because I'm going to be circling different numbers, okay? We have 27, and we have 54. I am going to write it again because I'm going to end up circling different numbers here. Okay, so we have G, C, F. Again, we work backwards. And just, you know, in a lot of math problems or a lot of things that you do in math, you take the name of what they want you to do and you just work backwards. It's kind of like a little tip. So when you get into like algebraic stuff in 7th and up, just keep that in mind. All right, so F, you're going to list the factors. All right, so 123. Well, we're going to start with 1 times 123. Now, one of the tips, 3 plus 2 plus 1 equals 6, okay? That is divisible by 3. So if you divide 123 by 3, you're going to get 41. All right? Next, you have 54. We have 1, 2, 3, 6, 9, 18, 27, and 54. It's 54, okay? And I'll draw the little rainbows here. Then 27, we have 1 times 27 with 3 times 9, okay? So, C, what do they have in common? 1, 1, 1, 3, 3, 3. And of the ones we circled, which is the greatest, that would be 3. So the greatest common factor is 3. Next question. Write each fraction in simplest form. Show your work. If the fraction is already in simplest form, write simplified. All right, so for question number 3, we're going to divide the top and bottom numbers by 5. and we get 5/7. For question number 4, you should divide by 7 on the top and the bottom, which gives you 2/8. And then you can divide by 2, and that would give you 1/4. Now, if you wanted to know what you could have done in just one step, you take 2 and 7 and you multiply it and you get 14. You could have simply divided by 14. Now, if you did that, you're super duper smart because a lot of kids don't know their 14 multiplication facts. So if you did that, bravo. Okay, next, divide by 6, and you would get 1/2. Then here, you're going to divide by 8, and you should get 1/3. Now you will see that sometimes I wrote my fractions with a slanted line, and other times I wrote it with a horizontal line. It's okay, you can write it either way. Next question. Richie purchased a pizza and ate 4 of the slices. This equates to 1/2 of the pizza. Write 1/2 as a decimal. Now, I'm thinking that you probably know off the top of your head what 1/2 is, and that is 0.5. But if somebody asks you to prove that, 1/2, okay? I always say that the denominator is always knocking at the door. So if this were a house, okay, the denominator is knocking at the door and the numerator is inside the house, okay? So we have 2 cannot divide 1, we add a 0, 2 can divide 10 5 times, which is 10, and you would get 5/10. Next problem. Question number 8. Leslie measured the height of her growing sunflower. The sunflower is currently 7/50ths of a yard tall. Write this fraction as a decimal value. All right, so we have 7/50ths. The numerator is going to go inside. Numerator inside. The denominator is knocking at the door. So if this is a house, it's knocking at the door. All right. Now, obviously, 50 cannot divide 7. So we're going to write a 0 in the quotient and a decimal point, and we're going to annex a 0. 50 is able to divide 70 one time, which is 50. We're going to subtract and get 20. And we add a 0, bring it down. Now I'm going to cover up the 0, cover up the 0. 5 is able to divide 24 times. 50 times 4, 0, 20 equals 200. And our answer ends in 0, so we're done. So it's 14 hundredths of a yard. Question number 9. 3 dogs are sharing 8 doggy biscuits. How many doggy biscuits does each dog get? Use a fraction to represent your answer. Now, this one I would, because it's a small number, 8 is not that big of a number, you could actually draw 8 dog biscuits, okay? I would probably do that, all right? So I'm going to draw ridiculous dog biscuits, though. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8 dog biscuits. only 3 dogs, okay? So is each dog going to get a dog biscuit? Actually, yes, each dog is going to get at least 1 dog biscuit. They're going to get 2. So each dog gets 2 for sure. Okay, and then we're going to have to split these up. And then they're going to be able to get 2/3, right? 1/3 and 1/3 is 2/3. So this would be 2 and then 2/3 of a dog biscuit. Because they'll get 1/3 of this dog biscuit and 1/3 of this dog biscuit. So that would equal 2/3. So now let's see if we can do that mathematically. All right. So we have 8 divided by 3. So 3 can divide 8 2 times, which is 6, which is 2. Now it says they want you to represent it with a fraction. So that would be remainder 2/3 because you keep your divisor as the denominator. Okay, so each gets 2 and 2/3 of a biscuit. Okay, now the amount of doggy biscuits each person gets, or dog gets, is between what 2 whole numbers? Well, that would be between 2 and 3. All right, find the least common multiple of each set of numbers. Show your work. Now, again, what I like about greatest common factors and least common multiples is the directions are right in the name. So least common multiple. We're going to work backwards. The very first thing we're going to do is multiply. All right, so we're going to make a multiplication chart. One, two, three, four, 5, 6. When you have 2 numbers, you only have to go to the highest number, okay, the largest number. So I have 4, 8, 12, 16, 20, 24, 6, 12, 18, 24, 30, 36. Then you can circle the ones they have in common, and they have 12, 12, 24, 24. This time, you're not looking for the greatest, you're actually looking for the least. In this case, it would be 12. All right, show your work for this one. Okay, so now we got least common multiple, and we have 3, 5, and 9, and we're going to make a multiplication chart for that. Okay. All right, so we have 1, 2, okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, and 12, 42. All right, then we have, now I might not go all the way just because I might not need to. All right, so then I have 15, I did that by 3, sorry. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. And then here I have 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99. Okay, now here I have 45 and then 45, and here if I go one more I'd have 45. Okay, so the answer would be 45. Okay, next 12. That was a longer answer, but you could do it. All right, circle the number that is not a composite number. All right, so 21 is a composite number because you have 3 times 7. 81 is 9 times 9. 51 is 3 times 17, and 71 is prime. So 71 is a prime number. All right. 13. Circle the number that is not a prime number. Okay, well, the one that is not a prime number, hopefully you can see it, it is 3 times 9, 27. Okay. Number 14, replace the circle with less than, greater than, or equal to make it a true statement. Okay, so I know you can cross multiply, but it's much better if you use common denominators. So what common denominator could we have for 5 and 4? We could make it 20. This means I'm multiplying by 4, multiply by 4, and gives me 12. Here I multiply by 5, multiply by 5 gives me 15, and which is bigger? 3/4. All right, now here I am going to write this over to the side just so I have some more room. I'm going to make this 42 and this 42, which means I would multiply by 7, multiply by 7, 14, multiply by 6, multiply by 6 is 18, and 3/7 is bigger. All right, question 16. Mr. Kramer is handing out paint for a school mural. Before starting, a layer of white needs to be painted to prime the wall. Now, when you're painting, especially with a colorful wall, you want to put white on there just to kind of like add that extra layer so that the color behind doesn't affect the tint of the color you're putting on it. All right, so a layer of white needs to be put on the wall. 7 students volunteered. Mr. Kramer has 16 bottles of paint. How much paint will each student be allotted? Represent this amount as a mixed number. Okay, so we have 16 bottles of paint. So again, this isn't a big number, so I'm going to draw 16. 1, 2, 3, 4, 5. Well, 6, 7. I'm going to do that, okay? And then 1, 2, 3, 4, 5, 6, 7. So it looks like everybody gets, that's 14, okay? 15, 16, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each student's going to get 2, right? And then we're going to have to divide this into 7, okay? So they're going to get 1/7 of this and 1/7 of that. So that's 2/7, okay, of a bottle, okay? So that's 2 and 2/7 of a bottle, okay? So let's see if that works. All right, so we have 16 divided by 7. So 0, 2, 14, subtract 2, 2 sevenths. So 2 whole bottles and 2 sevenths of a bottle. Okay? Next problem. Question 17. Keisha purchased 5 snacks at the store. The cash register printer was running out of ink, and she could not read the amounts on her receipt for 2 of the snacks. Can you figure out the amounts based on what she remembers? She's not sure what the chips are. She knows the soda was $2.20. The hot dog was $1.50. She doesn't know how much the sunflower seeds were. The chocolate bar was $2.30. The chips cost half as much as the soda. The total was $7.75. Okay. All right, so let's figure out what we know. The chips cost half as much as the soda. All right, so the soda is $2.20. So $2.20 divided by 2 would be 1, 1, 0. So the chips cost $1.10. All right, so I'm going to cross this off. It's $1.10. All right. The total was $7.75. So I have to add up all of these prices first. So I have $1.10, $2.20, $1.50, $2.30. I'm going to add up all of that. 0, 5, and this is 5, 10, 11. Carry the 1. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 7. So it's 710. Okay. So I have 710. And then I'm going to take that away from 775. That means the sunflower seeds were 65 cents. Okay. All right, explain how you determine the price of each. Okay, so for the chips, I divided $2.20 by 2 and got $1.10. For the sunflower seeds, I added the prices for the chips, soda, hot dog, and chocolate bar. And got $7.10. I then subtracted this amount from $7.75 to get the price of the sunflower seeds, which equals 65 cents. Question 18. Henry ran 45/75 of a mile. Write this fraction as a decimal. Now remember, the numerator goes inside as the dividend, and the outside is going to be your divisor. Oh, sorry, yeah, your divisor. Okay, so we're going to add a decimal point and a 0 because 75 cannot divide 45. Okay, so it's going to look like this when we start. To estimate, I cover up the last digits. Okay, 7 is able to divide 45 6 times because 7 times 6 is 42. So off to the side, I'm going to do 75 times 6. 30, 42, 43, 44, 45. Oh, that's perfect. Look at that. 0.6. So that is 6/10. Now, which number would go with 6/10? Right here, that's equivalent. Okay, 0.6 and 0.60 are the same value. All right, moving on. Question number 19. Olivia cut 12 pink roses and 16 white roses from the bushes in her backyard. If she wants to make some identical flower arrangements with no flowers left over, what is the greatest number of arrangements Olivia can make? When you see a question that says, what is the greatest number of arrangements, the greatest number of like things or the greatest number of common things, this is a greatest common factor problem, okay? Whenever you see wording like this, where something's in common or the same, that is a greatest common factor problem. So what you want to do now is figure out what the greatest common factor of 12 and 16 is. We're going to list the factors. 1, 12, 2, 6, 3, 4. 1, 16, 2, 8, 4, 4. Now we're going to circle the ones they have in common. Oops, no, not 3. I was moving a little too fast there. 4, 4, okay. And of the ones you circled, 4 is the greatest. Okay, so what does this mean? Okay, it means that they're going, okay, so it says here, if she wants to make some identical flower arrangements with no flowers left over, what is the greatest number of arrangements Olivia can make? So she's going to make 4 flower arrangements, okay? So she's going to have 4 arrangements. So look here. See how this 4 is connected to the 3? That means that these were the roses, and these are the pink roses, and these are the white roses, okay? So this 4 is connected to the 3, so that means that there's going to be 3 pink, 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 pink. Now this 4 is connected to 4, so that means you're going to have white, 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 white. Okay, but you're going to have 4 arrangements. All right. So again, greatest common factor. Common means, the word common means the same. All right. And here this problem is referring to having arrangements that are the same. So when they say that they're looking for arrangements that are the same and the greatest number of the same arrangements, you got 2 words that are telling you that this is a greatest common factor problem. Question number 20. It's snack time at the zoo. Each animal gets a small treat for their good behavior. Timmy the tiger ate 2,500 pounds of food. Millie the monkey ate 1/5 pounds of food. Patty the panda ate 1/3 pounds of food. Alan the alligator ate 3/4 pounds of food. And Chelsea the cheetah ate 1/4 pounds of food. Which two animals ate the same amount? Which animal ate the least? Which animal ate the most? Okay, now let's see here. I think a chart would actually help us out here, okay? So we got the tiger, 0.25. Then we got the monkey, 1/5. And then we got the panda, 1/3. And then we got the alligator, 3/4. And then we got the cheetah with 1/4. All right, now I have to say, I would probably turn these into decimals. Now some of them are, I'm hoping you know that some of these are by memory, okay? I'm hoping you know that 1/4 is 0.25. Okay, that should be one that you have committed to memory, all right? If not, I'm gonna actually prove it to you now, all right? So we have 1/4, that's what we're gonna do. 1/4, 1/4. 1 divided by 4, okay? 0. Point. Okay, so this is 2, 8, 2, 0, bring this down, 5, 20, 0. Okay, so that's 25 hundredths, okay? So this is 0.25. All right, now let's do the alligator, which is 3/4. So we have 3/4. That's 3 divided by 4. I hope you know that that's 75 hundredths. If not, that's okay. 7 times 4 is 28. Okay, do you see how that's 75 hundredths? Okay, 0.75. All right, next we have 1/3. Now again, 1/3 is one that at some point you should remember is 0.33333 repeating. Okay, this is 1 divided by 3. Can you see how this just keeps going on and on and on and on and on? Okay, well, it's going to just get 1. All right, so that's 0.3 repeating. All right, and then 1/5. Is 0.0 or 0, the decimal 2, or 2/10. Okay. All right, so which two animals ate the same amount? It looks like the cheetah and the tiger. Which animal ate the least? Millie the monkey. Which animal ate the most? Alan the alligator. Now, if you wanted to, you could always compare fractions by, creating equivalent fractions or cross multiplying. That's fine. Now, my thought process here is If you have to compare multiple fractions in a situation like this, it is easier to create decimals, okay? If you're gonna have to compare one to one and then another to another, it is easier to just make them all decimals, okay? If you're just comparing two fractions, I would say keep them fractions. But if you have to, compare a whole bunch of fractions to each other, it would be easier to make them decimals. Okay, time to find the unknown. All right, our fraction is getting smaller, so that means we're going to have to divide. So what did we divide by? We divided by 9. So we're going to have to divide by 9 here. So r equals 2. All right. And that, my friends, is the end of our study guide. So I wish you good luck and study. And again with math, draw pictures, check your work, write neatly, and make sure you read the question and do your very best. All right, have a great day.